More than 16,000 frontline missions were completed in just 1 month by machines that do not get tired, do not feel fear, and never need to be evacuated when enemy fire begins. That number points to a quiet but significant change in the war in Ukraine. For years, this conflict has been measured by the number of tanks, artillery systems, missiles, and soldiers each side could bring to the battlefield. But by the middle of 2026, another force was moving steadily closer to the front. It was crossing exposed roads, entering areas watched by drones, and carrying out missions that once placed human lives at the highest level of risk. These machines are small enough to move through trenches and along tree lines, affordable enough to be produced in large numbers, and flexible enough to transport ammunition, equipment, and even wounded soldiers. Their growing presence comes at a time when both sides are facing increasing pressure. So why has Ukraine decided to invest so heavily in ground robots while the fighting remains as intense as ever? How are these machines changing the way the battlefield operates, and can they really help Ukraine offset Russia's advantage in manpower? Join us on Military Force as we take a closer look. After more than 4 years of war, manpower has become one of Ukraine's hardest resources to replace. Weapons can be repaired, vehicles can be rebuilt, and ammunition can be produced again. But experienced soldiers cannot be restored on the same timetable. Every death or serious injury removes more than one person from a unit. It can also erase technical knowledge, battlefield judgment, and small unit leadership that may have taken months or years to develop. This pressure is especially serious for Ukraine because the country is fighting a larger opponent while also trying to preserve enough trained personnel for a long conflict. The challenge is not limited to the front line. Drivers, medics, engineers, signal operators, and supply teams are also exposed to drones, artillery, and surveillance systems. As the danger zone expands, routine movement behind the trenches can become nearly as risky as direct combat. Ukraine's answer is to move more machines into roles that once depended on people. Ground robots are now being introduced not as isolated experiments, but as part of a wider effort to protect soldiers and reduce the number of human lives placed inside predictable danger zones. That transition may help Ukrainian formations preserve their strength while maintaining essential operations under constant pressure from Russian fire systems. The pace of deployment suggests that this effort is moving beyond small trials. According to figures cited in the source transcript, Ukrainian ground robots completed 7,511 missions in January 2026. That number rose to 7,960 in February, 9,072 in March, 11,028 in April, and 14,059 in May. In June, the total passed 16,600 missions, which would represent an increase of about 122% from January. These figures matter because they show a steady rise rather than a one-month spike. Ukraine appears to be building a permanent robotic support system for the battlefield, one that requires operators, repair teams, spare parts, secure communications, and reliable supply chains. The machines themselves are only one part of the program. Without maintenance and trained crews, large numbers would quickly become an expensive collection of damaged platforms. The scale of procurement points in the same direction. The transcript refers to about 25,000 ground robots contracted during the first half of 2026, and a production goal of roughly 50,000 by the end of the year. Those numbers still require independent confirmation, but they suggest that Kyiv sees UGVs as a national defense priority rather than a temporary wartime experiment. Producing thousands of robots, however, will matter only if they can remove soldiers from the most dangerous missions close to the front. It will also show whether Ukraine can turn battlefield necessity into a durable military institution rather than a temporary emergency response alone. Modern warfare has changed the meaning of frontline logistics. Delivering ammunition, food, water, batteries, and medical supplies was once treated as a support task behind the main fighting. In Ukraine, those routes are now often watched by reconnaissance drones, thermal cameras, and artillery observers. A short journey across an open field or damaged road can expose soldiers to the same danger as a direct combat mission. Ukraine is trying to reduce that risk by moving unmanned ground vehicles into supply roles. These machines can carry ammunition boxes, communication equipment, engineering tools, and supplies toward forward positions. Their purpose is not only to move cargo, they also reduce the number of people who must leave cover and enter areas where enemy drones are searching for movement. Every avoided journey matters. When a robot travels through an exposed corridor, a highly trained soldier can remain inside cover and continue supporting the unit. Ground robots are useful because many supply routes are easy to predict. Roads, tree lines, trench entrances, and narrow paths may be watched for hours before any movement begins. Once a target appears, strike drones or artillery can be directed toward it quickly. Using a robot changes the risk. If the machine is destroyed, the unit loses equipment that can be repaired or replaced. If a soldier is killed or wounded, the loss includes training, battlefield experience, and the ability to perform other duties. That is why UGVs are increasingly valuable in repeated tasks that do not require human judgment. They can make trips on the same route, deliver smaller loads, and reduce the need for soldiers to move in groups. This does not make the route safe, but it shifts part of the danger from people to machines. This also gives commanders freedom to preserve scarce personnel for defense, observation, coordination, and rapid responses during sudden battlefield changes. Casualty evacuation may be one of the most important uses of ground robots. Recovering a wounded soldier is often dangerous because rescue teams must enter the same area where the original strike took place. The enemy may still be watching, and a second attack can cause additional casualties. A UGV can provide another option. It can move toward the injured person, carry that soldier away from the exposed area, and bring the casualty closer to medics. Medical personnel are still needed, but the robot can handle the most dangerous part of the movement. This role is useful in open terrain, along damaged roads, or near positions where vehicles cannot approach safely. It may also help units respond faster when artillery fire, drones, or mines make a normal evacuation difficult. Beyond evacuation, some platforms can pull communication cables, carry mines, move FPV drones toward launch points, support reconnaissance, or transport remote weapon modules. Ground robots are expanding their role, but they are not replacing infantry. They cannot clear buildings, secure trenches, identify civilians, or make complex decisions in a changing environment. Soldiers are still needed to hold terrain, respond to unexpected threats, and judge situations that cannot be reduced to a simple route or command. The main value of UGVs is limited and realistic. They remove repetitive support tasks from soldiers and allow trained personnel to focus on missions that require human judgment. In that sense, robots are not replacing the army. They are changing how the army uses its people. There are still limits. Trees, destroyed buildings, uneven ground, and electronic warfare can interrupt signals or reduce operating range. A robot may stop, become stuck, or fail before reaching its destination. Reliable communications, trained operators, maintenance teams, and spare parts are therefore essential. Saving lives is only one part of this shift. These machines are also changing the cost and efficiency of every supply mission, which leads directly to the economic argument behind Ukraine's investment in UGVs. Unmanned ground vehicles create a different economic calculation because their price can be measured directly, while the loss of a soldier carries costs far beyond salary. A ground robot may cost between $2,000 and $40,000, depending on its size, payload, sensors, communications, and protection. A trained soldier represents recruitment, instruction, equipment, medical support, and months or years of accumulated experience. That difference matters in a long war. A damaged robot can be repaired, replaced, or used for spare parts. A wounded soldier may require evacuation, treatment, rehabilitation, and a replacement who must be trained before joining the unit. The military cost therefore includes lost time, reduced unit performance, and added pressure on the personnel system. For Ukraine, the logic is simple. When a machine can complete a dangerous support task, using a person may become the more expensive choice, even before the human consequences are considered. Unlike most armed FPV drones, logistics robots are not designed for a single attack. A reliable platform can complete repeated supply runs, return to its operator, receive repairs, and go back into service. This changes how commanders should judge its value. A robot purchased for $20,000 may appear expensive as one item. However, if it completes 40 missions, the basic purchase cost falls to $500 per mission before maintenance is added. The more often the platform survives and returns, the greater its economic value becomes. Reuse also creates flexibility. The same vehicle can carry ammunition on one trip, batteries on another, and engineering equipment later. A unit does not need a separate machine for every task. The advantage, therefore, depends on service life. Durability, battery performance, and ease of repair may matter more than advanced features that raise the initial price, but provide little benefit under battlefield conditions. UGVs also reduce the value concentrated in each target. A large truck may carry many supplies at once, but it also places cargo, fuel, equipment, and sometimes personnel in one visible platform. If that vehicle is destroyed, the loss can delay several operations. Small robots allow Ukraine to divide one shipment into several lower-value movements. This method may require more trips, but it reduces the amount lost in any single strike. It can also force the enemy to spend more time, drones, and ammunition to stop the same total quantity of supplies. A light robot cannot replace every truck, especially when large amounts of fuel, heavy ammunition, or construction material must move. Its value is highest where smaller deliveries are frequent and exposure is severe. A national UGV program could still require investment. If Ukraine produced 50,000 robots within the stated price range, the theoretical cost would fall between $100 million and $2 billion. The true figure would depend on the average model, included equipment, batteries, control stations, maintenance, and training. Even the upper estimate may be manageable within modern war, but purchase price alone can mislead. A cheap robot that loses connection, becomes trapped, breaks its tracks, or waits for spare parts may cost more over time than a reliable design. Economic efficiency therefore depends on the support system. Units need trained operators, repair teams, standard components, charging equipment, software support, and dependable communications. They also need data on failure rates and mission success. The strongest program will not be the one that buys the cheapest machines. It will be the one that keeps the greatest number working at the front. Ukraine's advantage in ground robotics does not depend on finding one perfect machine. It depends on how quickly battlefield problems can become new designs. Units identify a need, manufacturers build a prototype, soldiers test it, and the results return to engineers for revision. That cycle can move faster than a military procurement process. This matters because the battlefield changes constantly. A platform that works on dry roads may fail in mud. A communication system that performs in open fields may lose contact near tree lines or damaged buildings. Russian electronic warfare may force developers to change control links, antennas, or navigation software. Ukraine's model allows these weaknesses to be discovered and corrected before production expands. Ukraine codified 67 new types of ground robots during the first quarter of 2026. That figure requires verification because different variants may be counted separately. Even so, the claim points to an effort to create platforms for transport, evacuation, engineering, reconnaissance, and other battlefield roles. A second part of Ukraine's system is the connection between frontline demand and military purchasing. Through the DOT chain defense marketplace, units can use points earned through combat performance to request equipment they consider useful. The value of this model is practical. Troops operating in forests may prefer compact tracked vehicles, while units on open ground may need greater range and heavier payloads. A central office may not understand those differences, but commanders face them every day. Their choices can show manufacturers which designs are working. 1,028 ground robots were delivered through this system in May, while total orders reached 3,062 platforms worth about $46.6 million. These figures should be attributed, but they suggest that demand is being shaped by users rather than only by planning. Competition strengthens that process. Companies must improve durability, control range, payload, battery life, and mobility if they want orders. Designs that fail in combat can lose support quickly, while reliable systems can enter larger production runs. This pressure rewards practical machines that survive field use, while designs built around untested features may disappear before receiving wider military support. Russia is also developing unmanned ground vehicles, so the comparison should not suggest that Moscow has ignored robotics. Russian firms have produced platforms for transport, mine clearance, reconnaissance, and combat support. The difference appears to be the speed at which designs reach frontline units. According to the transcript, Russia has about 20 companies producing 29 types of ground robots, while 12 of those companies are under Western sanctions. Sanctions may restrict access to electronics, sensors, and components, but they do not explain the gap. Procurement systems, testing procedures, production capacity, and battlefield feedback shape how quickly a design becomes operational. Ukraine's system is not without risks. Too many models can create problems with batteries, spare parts, software, training, and repairs. Kyiv may need to reduce the number of platforms and focus production on a smaller group of designs. The real advantage is not variety alone. It is the ability to identify failure, correct it quickly, and return an improved machine to the front. That difference becomes clearer when Ukraine's robotic system is compared with the manual supply methods Russian troops still use on some battlefields. While Ukraine is expanding the use of unmanned ground vehicles to reduce risk along the front, Russian forces in several sectors continue to rely heavily on soldiers to carry supplies during the final stage of resupply. Trucks, armored vehicles, and light transport still move equipment through the rear, but approaching frontline positions has become increasingly difficult. Reconnaissance drones can monitor roads, tree lines, and open terrain for long periods before directing attacks against moving vehicles. Because of that constant surveillance, many vehicles cannot safely complete the last part of the journey. Instead, supplies often have to be unloaded farther from the fighting. Soldiers then carry ammunition, food, drinking water, batteries, medical equipment, and other essential materials across exposed ground. This method may reduce the risk of losing an entire vehicle, but it also transfers much of the danger directly to the people responsible for completing the final delivery. As drone coverage continues to expand, even routine logistics missions can become high-risk operations. According to Ukraine's 34th Separate Marine Brigade, Russian soldiers operating on the Kherson axis have been forced in some areas to walk about 10 to 11 kilometers while carrying supplies to frontline positions. This remains a Ukrainian claim and has not been independently verified, but it illustrates how Kyiv describes the pressure facing Russian logistics in that sector. Long distances create several practical difficulties. Heavy ammunition, food, water, communication batteries, and engineering equipment slow movement and increase physical exhaustion. Soldiers carrying large loads cannot react as quickly when drones appear overhead. They need more time to change direction, find cover, or disperse across open ground. Even without direct enemy fire, fatigue alone can reduce the speed and efficiency of every supply mission. The longer the route becomes, the more opportunities reconnaissance drones have to observe movement. Every additional kilometer increases the chance that a supply team will be detected before reaching its destination. Modern reconnaissance drones do not always attack immediately after finding a target. In many cases, they continue observing movement, identify the destination, and provide targeting information for strike drones or supporting artillery. This allows attacks to occur at the moment when the target is most vulnerable. For soldiers carrying supplies, that creates a difficult situation. Their routes are often predictable, their speed is limited by heavy equipment, and their ability to escape quickly is reduced. Even if they survive an attack, They may be forced to abandon ammunition, food, medical supplies, or communication equipment before reaching the unit waiting for those resources. A logistics mission can therefore fail without causing casualties. If essential supplies never arrive, frontline units may delay operations, reduce their rate of fire, or wait for another delivery under equally dangerous conditions. The soldiers carrying equipment represent only the final link in a much larger supply system that Ukraine is increasingly trying to pressure from the rear all the way to the front. Ukraine's pressure on Russian logistics does not stop near the trenches. Kyiv is trying to disrupt the wider system that keeps Russian forces supplied, from storage sites in the rear to the final routes leading toward frontline positions. Potential targets include fuel depots, ammunition warehouses, railway links, transport vehicles, command posts, air defense positions, and drone launch areas. Each strike affects a different part of the structure that allows Russian units to continue operating. This campaign works in layers. Long-range drones can reach facilities deep behind the front, where fuel, ammunition, and equipment are stored or transferred. Medium-range systems can attack trucks, rail movements, and temporary supply points closer to combat zones. Near the front, FPV drones and artillery can target vehicles, delivery teams, and positions receiving supplies. The aim is not to depend on one decisive blow, but to create repeated pressure at every stage of movement. Ukraine does not need to destroy the entire Russian logistics network at once. It can gain an advantage by forcing Russia to move depots farther away, divide convoys into smaller groups, change routes, increase security, and spend more time repairing damaged infrastructure. Supplies may still arrive, but every adjustment makes delivery slower, more expensive, and harder to coordinate. Automation supports this pressure by allowing smaller Ukrainian units to observe more territory and conduct more missions with limited personnel. Ground robots move supplies. Reconnaissance drones search for activity. Strike drones attack exposed targets. And electronic warfare systems disrupt enemy communications. None of these tools creates more soldiers, but together they increase what each unit can monitor, reach, and influence. The main advantage comes from connecting these systems. A drone that detects a vehicle has limited value if the information arrives too late. Ukraine therefore needs rapid links between reconnaissance teams, commanders, artillery crews, electronic warfare units, and drone operators. The shorter the time between detection, decision, and attack, the less time Russian forces have to move or hide. This model does not remove the need for infantry. Soldiers are still required to defend positions, seize ground, and make decisions in complex conditions. Ukraine's broader goal is to reserve people for tasks that require judgment and physical control, while machines handle work that creates exposure without requiring direct human presence. That principle connects battlefield robotics with a wider campaign to weaken Russia's ability to sustain the war across an increasingly transparent battlefield. Ground robots will not decide the war in Ukraine alone. Terrain, signal loss, electronic warfare, mechanical failure, and maintenance demands will continue to limit what these systems can achieve. Their importance lies elsewhere. UGVs allow Ukraine to protect trained personnel while keeping support moving under pressure. The real measure of success is not only the number of missions completed, but also the number of soldiers who no longer have to cross exposed routes. This creates a clear contrast. Ukraine is trying to move risk from people to machines, while Russian troops in some sectors still carry supplies through areas watched by drones. The next stage of this competition will depend on communications, repair networks, data links, and command systems. In a long war, technology cannot replace human judgment or infantry. It can, however, help an army preserve its people, sustain operations, and remain effective against a larger opponent much longer. If you found this analysis helpful, please subscribe to the channel and stay with us for more in-depth coverage of today's most important military and geopolitical developments. Our goal is not to celebrate war, but to understand how modern conflicts are changing, how technology is reshaping the battlefield, and why these changes matter far beyond the front lines. The better we understand war, the greater our chance of understanding the value of peace. Thank you for watching, and we will see you in the next report.